We all know that different psychoactive drugs feel, well, different. A stimulant is nothing like a hallucinogen, right? But have you ever wondered what that difference actually looks like inside a living, working brain? Well, today, we're going to see it.
So, how exactly does a drug redraw your brain's energy map? To answer that, we're diving into a really groundbreaking study from 1999. Researchers used some amazing brain imaging tech to create the very first energy maps of the mind under the influence of 3 totally distinct substances.
First up, we've got psilocybin. You probably know this as the active component in magic mushrooms. It's a classic hallucinogen, famous for producing these really profound, sometimes reality-bending shifts in how we see, think, and feel.
Next on the list is MDE. Now, this one's a close cousin of MDMA, or ecstasy. It's part of this really unique class of drugs called entactogens. These are substances that mainly dial up our emotions, creating these intense feelings of empathy and connection. The researchers saw this as a fascinating middle ground, somewhere between a stimulant and a hallucinogen.
And finally, rounding out our trio, we have d-methamphetamine, a classic, very powerful stimulant that, as you know, ramps up energy, focus, and drive. So, okay, we've got 3 very different drugs promising 3 completely different experiences. Let's see what that actually looks like inside the brain.
So how in the world do you peek inside someone's brain to see this stuff happening in real time? Well, the scientists needed a special kind of camera, one that could see not just the brain's structure, but its activity, its energy. And the tech they use is just incredible.
They used something called an FDG-PET scan. The easiest way to wrap your head around this is to think of it as tracking fuel consumption in a car. The scanner can see where the brain is burning the most glucose. That's its main fuel source. This creates what is literally a heat map of the brain's energy use. More color means more energy, which means more activity. Simple as that. Now, to make any sense of this flood of data, the researchers needed a map. So they carved up the brain into 37 distinct regions of interest, or ROIs. You can think of these like specific neighborhoods in a city. This let them precisely measure and compare energy use in very targeted areas, from person to person and from drug to drug. All right, so what did they find? The first set of scans happened while people were in a pretty simple baseline state, basically just lying there, repeating words they heard. But even in this quiet state, the drugs revealed 3 totally different brain energy signatures. And wow, this slide just says it all. On the left, you've got a brain on a placebo. Looks pretty normal, right? Balanced activity. But look at the brain on the right, under psilocybin. The change is just staggering. See all that bright red and yellow right at the front? That's the frontal cortex going into overdrive. And at the same time, look at the center of the brain. It's gone cold, dark blue. Let's break that down a bit more. This chart shows us exactly what's going on. The anterior cingulate, which is a major hub for our emotions and attention, its energy use just skyrockets by almost 10%. But at the exact same moment, the thalamus, which acts as the brain's sensory filter or gatekeeper, saw its energy use plummet. So in other words, the emotional centers are supercharged, while the gate that normally filters all the sensory information coming in is just thrown wide open. Now, compare that to MDE and methamphetamine. They showed a completely different pattern, and what's really wild is how similar they were to each other. Instead of lighting up, their frontal cortex actually cooled down, got quieter. But the biggest surprise was the cerebellum, at the back of the brain. Both drugs caused a massive energy surge there, over 10%. And this was a huge deal, because back then, most people thought the cerebellum was just for motor control, not these complex experiences. So let's just boil this down, because this is the key point. We're looking at 2 fundamentally opposite states. Psilocybin creates a hyperfrontal state, an overactive cortex, paired with an underactive thalamus. MDE and meth, on the other hand, create a hypofrontal state, an underactive cortex, but with a surprisingly overactive cerebellum. 2 completely different paths. This brings up a really interesting question, though. The brain on psilocybin looks supercharged when it's just resting. But what happens when you actually ask it to do something? What happens when you put these brains under a bit of cognitive pressure? So the researchers used this really simple but clever test. For 32 minutes, subjects just listened to a long list of common nouns, and their job was to say the very first word that popped into their head. It's a task that's specifically designed to make you focus and fire up your prefrontal cortex, the exact same region that was already buzzing like crazy on psilocybin.
And here it is. This is the crucial finding. The placebo group on the left shows exactly what you'd expect. You give them a task, and their frontal lobes light up to get the job done. But now look at the psilocybin group. Their frontal activation was just flat. It was completely blunted. So even though their cortex was hyperactive at rest, the brain couldn't actually focus that energy to perform the task. The lights were on, but nobody could direct the beam.
And this wasn't just some abstract image on a screen. This had real-world consequences. That blunted activation translated directly into a 23% drop in performance on the task. The people on psilocybin just couldn't come up with as many words. The energy was there, sure, but it was chaotic, unfocused, and couldn't be harnessed for a specific goal.
So, let's put all the pieces together. What does this all mean? The study came to some really powerful conclusions that have implications not just for these drugs, but for how we think about mental illness itself.
Okay, this boils down to 3 huge takeaways. First, that psilocybin brain state, hyperactive at rest but unable to focus that energy, it turned out to be a powerful model for psychosis. In fact, it looked remarkably similar to brain scans of patients who were experiencing acute schizophrenia. Second, MDA and meth showed us a totally different pattern, a quieted cortex and a fired-up cerebellum. And third, MDA really proved it was a true hybrid, which helped solidify its place in its own unique class, the entactogens. And this finding was such a big deal that the researchers basically said they had found clear neurobiological proof. Drugs like MDMA weren't just weird stimulants or weak hallucinogens. No, they were their own thing, a distinct class, the entactogens, carving out their own unique space on the map of the mind.
So, what's the big picture takeaway from all of this? These scans show us in vivid color that our entire subjective reality, everything we see, think, and feel, can be completely transformed just by rerouting the brain's energy. It really makes you wonder, doesn't it? If our consciousness is so deeply tied to these energy maps, what does that tell us about the very nature of our everyday awareness?